Dear students, Namaste. So let us start the second part of our class of the chapter Algorithm and Flowchart. In this, we are going to see detail about the flowchart. Today, we are going to learn about flowchart, symbols used in flowchart, rules for drawing flowchart, conditional statements, looping statements. This we have also covered in algorithm, and we will see how to convert an algorithm to flowchart. What is a flowchart? A flowchart is a pictorial or graphical representation of an algorithm. In flowcharts, each step is represented in the form of a geometrical shape. Each shape represents a particular use. These shapes are connected using arrows to show the sequence of flow of steps. Different shapes that are used in flowcharts and the uses. We'll discuss it now. First is a oval or rounded rectangle. It is known as start or stop box. It is used to show the start and end of a flowchart. Next is rectangle. It is also known as process box. It is used to show the process or action, that is any calculation or the processing is written inside this rectangular box or the process box. Next shape is parallelogram. It represents the input or output, and we see it as an input or output box. It is used to show whether data is input or it is the output. Next is the diamond shape or the diamond symbol. Its name is the decision box. It is used when you use to select between two options, commonly used as a yes or no. The last one is the arrow. This is also known as flow line. It is used to connect different shapes in the flowchart and indicates the direction of the flowchart. As in algorithm, we are using variables and other symbols. In flowchart also, we use those. We are going to discuss this in brief. The variable names are used to store the values. The values stored in the variable can change in the solution steps. In addition, some special symbols are used as shown below. First is the assignment symbol, that is equal to, is used to assign value to the variable. Next are the mathematical operators, relation operators, and logical operators. Let us discuss about these. Mathematical operators. The operator basically we know are symbols. So here plus sign or plus symbol, it means addition. Example a plus b, minus subtraction, asterisk is the multiplication, then slash is the division, that is the backward slash, then caret is the power, and in some particular programming language we use percent sign and some we use mod operator. So this is also known as a reminder, and it is example is a% b or a mod b. So this is used to find the remainder of a particular division. Relation operators. The operators are less than, equal to, not equal to. Here see the sign having less than and greater than sign together in opposite direction. This is basically used in QBasic. In some it is hashed, or in some it is the exclamation sign and equal to, then greater than sign and greater than equal to sign. These are the relation operators which give the output as true or false. Logical operators. Logical operators are and or and not. The logical operators take two relational expressions as operand and they give the output as the logical values, that is true or false. Here the example is a less than b is a relational expression. It can give our value true or false, and similarly b less than c also can give true or false. So the output of this expression will be true only if the value both a less than b and b less than c are true, otherwise it is false. Similarly, for OR, it is a less than b or B less than C. It will be true if any particular statement, that is the relation expression value, is true or both are true. It will false if both the relational expressions are giving the false value. Last is not A greater than B. It is going to negate the particular value that we are going to get from the relational expression. If A greater than B value is true, then it will make it false. So these are the logical operators. We are going to see a little bit of it in higher class. You are going to see in detail. Rules for drawing flowcharts. The direction of flow in a flowchart is either from top to bottom or from left to right. Arrowheads are used to indicate the directions of the flow of actions or flow of control. A flowchart should have one start and one stop box. A flowchart should have short, clear, and readable statements written inside the symbols. Characteristics of a flowchart. It should contain enough white space as to not look cluttered. White space means the empty space. Second, it should consist of standardized and acceptable symbols. The symbols should be correctly used according to flowchart rules. The flowchart should have short, clear, and readable statements written inside the symbols. It must have a clear one starting point and one ending point. Must flow in a logical order. It should have acceptable and common keywords such as read, input, print, or write. And it must have arrows indicating the flow of instructions or the controls. Basic control structures. We are going to see in detail about this. Basic control structures are sequence, selection, and loop. Sequence. It means the steps that execute in sequence are represented by symbols that follow each other top to bottom or left to right. Usually, top to bottom is the shorthand. You can see the particular figure here. It is showing the sequential control or the sequential flow of statements. First the flow will come to process 1, then it will go to process 2, and then it will go to further down. So this is the in sequence. Let us see the sequential example of sequential flow of control in a flowchart or an algorithm. Step 1, start. Step 2, input length, say L. Once we are getting the input, then we'll go to step number 3 where breadth, say B, is a variable. The value will be asked from the user. Next is step 4 where it is processing. Area is equal to L into B. It will process and the value or the result will be stored in area. Then step 5, print area, that is it is going to display, and the step 6 is stop. Similarly, the flow chart, it is showing the start symbol at the beginning. Then see the step number 2 is replaced by the parallelogram where we have written input L, same as that of the algorithm. Step 3, see the step 3 and the third particular diagram of the particular flow chart. It shows input B. So after that is area, which is a processing box, because area is equivalent to B is a processing. So it is a rectangular box and it specifies the processing. The step 5 is print area. So we have a parallelogram where inside we have written print area. It is showing the output. The print statement is used for output, and the last one is stop. So see how we have converted the algorithm into flowchart, and here the control is in a sequence way, means it starts from the beginning and it doesn't deviate anywhere and it stops in the stop box. I hope it is clear. Let me take Another example where we can show, or I can show you, the sequential flow of control. Here, algorithm and flowchart to find the sum of two numbers. Step 1, start. As soon as we say start, it means that we have to collect, or the system have to collect, all the resources which is needed to start the program. So here, algorithm step 1 is start. If you see the corresponding flowchart, the first figure is your start or stop box. Here we are writing start because it's starting. Next, step 2, input first number, say A. The corresponding flowchart diagram is also depicting a parallelogram where we have written input A. It shows that it is a input box and it is going to accept a input, and which is going to be stored in variable A, that is a number. Then step 3, input second number, say B. So here the corresponding figure in the flowchart is again a parallelogram which represents an input or output box. Since input B is written, it is an input statement. Next is sum is equal to A plus B. It is a processing. So we have a rectangular box which depicts the processing, that is sum is equal to A plus B. Then the next one is display sum. So we have the corresponding print statement, and in the parallelogram which is again depicting input output box, so it is a print return, so it is a output statement or the output box. And the last one is step 6 is stop, so it is represented again as a start stop box is there, which is written stop, means it is going to terminate the particular flowchart. Selection. In this, once the condition is validated, the control flows into one of the two paths. Means the flow of the control depends on the condition. Therefore, the condition is going to select the path. It will not be a sequential one. So once the condition execution is finished, the flow rejoins before leaving the structure. See here, it is showing question mark. That means the condition is there. If condition is yes, then process 1 will be executed. If condition is no, then process 2 will be executed. After that, it is going to go for the next particular process, that is maybe process 3. Let us see the example. We are going to see the algorithm flowchart to find the largest of two numbers. So step 1, start. The corresponding in the flowchart symbol is start, stop box, and we are writing start because we are going to start the flowchart. Next, step 2, input two numbers, say num1, num2. So this is the input, that is a parallelogram symbol should be there. Yeah, parallelogram is there, and there we have written the input value for num1, num2. Next, step 3, if num1 is less than num2, then print largest is num1. So here the control is now depend on the output of num1 and greater than num2 condition. If this condition is true, then print largest is num1 will be executed, or the control flow to this particular one. If it is false, that means if num1 is not greater than num2, it is less than num2, then the control will come to the print largest is num2. So it is depicted with the help of, since the condition is there, so a decision box or a diamond is being there, and inside the decision box we have written the condition if num1 is greater than num2. If it is yes, the print largest is num1 will be executed. If this is false, then print largest is num2 will be executed or will be displayed. So this print and these two boxes are again a parallelogram, where it means that these are the input or output box. Since print is written, therefore it is a output box. And then it is going to, once this is over, then it will come to the stop. The last step is step 4 is stop. So we have the stop box at the last. Loop control. In this control, either the processing repeats or the control leaves the structure. Notice the return line joins the entry line before the question. Now see the figure here. The control line is coming from the top. It goes into this particular condition statement. It checks the condition. If condition is true, then it will go for the process, and then once the process is over, it will again come back and check the condition. Again, if the condition is true, it will repeat this whole process again till the condition becomes false. So this is a type of repetition or the looping control or looping construct. Let us see the example of a looping construct. Algorithm and flowchart to find even numbers between 1 to 50. Step 1, start. So the corresponding flowchart has also the start box, and in that is written start. Then step 2, I is equal to 1. Here I is a variable and we are assigning 1 to I. So it is a processing. So a rectangular box is there which indicates the processing. So I is equal to 1. Then if I is greater than 50, then go to step 7. So here the go to step 7 means if this is true, then the cursor or the control will go to step number 7, that is stop. If condition is false, then it will come to step number 4. And step number 4, it will again check the condition, that is I mod 2 is equal to 0, then display I. Here I mod 2, mod means is a remainder operator. So when I divide I by 2, if the remainder is 0, that means it is an even number, then it will display the even number. If it is false, then it will go to step 5, I is equal to I plus 1. And then it will come to step number 6. Here we are incrementing in step 5, we are incrementing the value of I by 1. And then we go to step 6, says go to step 3. Now it will go back to step 3 and then the whole process is repeated again. Checks the condition of I. If it is greater than 50, then it will come out of the loop. Otherwise, it will again go into step number 4 and step 6 continues till I becomes more than 50. Here, I is changing in step number 5. So similarly, let us see the flow chart. Step 3, we have the condition, that is the diamond structure or the diamond symbol, and inside it is written if I is greater than 50. If the condition is yes, then it is going to come out of the loop and the program stops. If it is false, then it will go and check the other condition. If I mod 2 is equal to 0, as I explained you in the algorithm, it will print I and then it will come back to the next step, that is a processing step. I is equal to I plus 1, and it is going to increment or add 1 to the value of I, and it continues till the particular I doesn't become more than 50. So here this particular is showing you the looping control or looping construct. I hope you have understood this. Between algorithm and flowchart. Algorithm, it is a procedure for solving problems. Flowchart, it is a graphical representation of an algorithm. Algorithm, the process is shown in step-by-step instruction, whereas in flowchart, the process is shown in block-by-block information diagram. Algorithm is complex and difficult to understand, whereas the flowchart is intuitive and easy to understand. Algorithm is convenient to debug errors, but in flowchart it is hard to debug errors. Algorithm is somewhat easy to solve complex problems, whereas the flowchart is hard to solve complex problem. Dear students, I am sure you have understood the concept of algorithm and flowchart. In the next class, I will give you some more examples of algorithm flowchart. Till then, have a nice time. Bye. See you in the next class.